Well, hey Top Devs, how's it going? Today we're going to be solving LeetCode question 198, house robber, medium question, and this is a good one. So you are a professional robber planning to rob houses along a street. Each house has a certain amount of money stashed. The only constraint stopping you from robbing each of them is that adjacent houses have security systems connected to it, and it will automatically contact the police if two adjacent houses are broken into on the same night. Given an integer array, so this is an integer array, nums, representing the amount of money in each house. So we're given an array of numbers representing the amount of money in each house. Return the maximum amount of money that you can rob without alerting the police. And so we have an example here of, I'm looking at this one. We have 2, 7, 9, 3, and 1. And the output is going to be 12. So what does this mean? It says you rob house 1 with money 2, which is right here. Rob house 3 with money 9, which is right there. And rob house 5 with money 1. And 2 plus 9 plus 1 is going to equal our 12. And so the total amount that you can rob is 291. So that means you can only rob houses that are, not next to each other. They can't be next to each other in this case. They have to be apart in the system, in the array. Okay, so I kind of drew a diagram here to kind of help this make sense. We're given this image, this illustration, and this array: 2, 7, 9, 3, and 1. And our output over here is 12. Okay, so what we're doing is, let's say we have a robber over here, and he's a bad man, and he's gonna go to house number 2. And basically he's gonna go to house number 2, and he's gonna say, look, if I rob house number 2, so if I rob house number 2, that's gonna, excuse me, house 0. If I rob house 0, because this is our 0 index right here, that's gonna give me $2 of profit. That sounds awesome. How about if I move over? He goes and walks down the street. He walks down the street, and now he says, I can rob either house number 2 or I can rob house number 7. I can't rob both of them because I know there's a security camera right there. Excuse me, there's a security system right there. And if I rob both of them, I'm going to jail. But if I rob one of them, I'll be good. So what I'm going to want to do is I want to rob, honestly, I'm going to rob house number 1. I want to rob the max of house 1, or house 0. So I want to either rob house and get a 2 for house 0 or a 7 at house 1. And obviously I'm going to rob 7 because that would give me the greatest, return on my robbery, if you will. And so what I'm going to want to do is, now I'm going to be at house 2, and I'm going to say I want to rob house number 2. And now I have three options here. I can rob either house 7, because I've only seen 3 houses in the street so far. So I could rob either house number 7 because it is the middle of the 3 houses, and I can't rob houses that are next to each other. I can't rob 2, and I can't rob house number 0 and house number 1. I have to rob house either 0 and 2 or house number 1. And so my answer is really going to be something like, well, I want the maximum amount of profit or loot or bounty that I can get for my efforts here. So it's either going to be the middle house, which is house number 1 with $7 in it, if you will, or house 0 and 2 with $2 and $9 in it. So I could say I'm either going to do a robbery for house number 7, excuse me, house number 1 with $7, or 2 plus 9, which is going to give me an $11 potential profit, which is pretty awesome so far. if I want to move forward from there, I want to say I want to rob house number 3. So our bad robber guy, he's going to move over to house number 3 now. And at house number 3, he's going to say, okay, I see what I can do here. I can either rob house number 3 and 0, or I could rob number of house 1 and 3, or I could rob 2 and 0, or if I haven't already mentioned it, 3 and 0, and I think I have already mentioned that. So I have a couple different options here, don't I? Well, I know from my previous example that if I was to rob, because I've already potentially considered robbing house number 2 here, and it would give me 11. So we're going to want to maximize our profit. And I already know that at house number 2, my profit for robbing house number 2 would be 11. So I can either rob house number 2 and it would be, the profits of 2 and 0, or I could rob, house number 1 and 3, and that would give me 7 plus $3 of profit, which would, still yield me with the 11 that I had before. So I'm hoping, as a robber, I'm hoping that there is more houses to rob, and we can move forward from there. So we take our robber, and he's going to move to the very, very last house. There he goes. And he's going to say, robbing house number 4. I know that I have already seen the potential of robbing house R3 of this house. If I already robbed this house, then my profit would be 11. So I know that 11 is the best I've seen so far. We can either rob house number 3 and 1, or we could rob, potentially a different house, which would be 4, 2, 0, or we could rob 4 and 0. So we have a lot of options at house number 4, but I want to save myself some time. I know that I've already calculated what would happen at house number 3, the amount of profit that I would make at house number 3. It's already here. The robbery at house number 3, that would give me 11. So I could either rob, calculate the new max, if you will, the new profit, if you will, from 4, or I could stick with number 3. Well, I'm going to say number 11, which is really the same as, I want to put R3 here, which is equal to 11. Or I could do something like this. I could say, well, I know I could rob house number 4, 2, and 0. What would that give me? Well, I already know what would happen if I was to rob house number 2. It's 11. So if I was to rob house number 2 and 4, what would I get? Well, I have R of 2 plus 1, which this 1 comes from right here. And that's equal to 11. And then R of 2 is 11 plus 1. And to make this even more clear, I'm going to say R of, excuse me, I'm just going to put this in maybe a different color, if that's okay. I'm going to use purple. I'm going to say this purple is the 1 right there. It's this 1. Okay? And obviously it's going to give us 12. So it looks like we kind of found a formula a little bit. If we write this in an array, then our array is going to look like this. It's going to be an array of 2, 7, 11, 11, 12. You're going to say, where are you getting this from? Well, we know that the 2 is going to be there. The 7 is going to be there. The 11 is going to be there, and the 12 will be there. So if this is the case, if we understand that we're kind of calculating a formula as we went down this line here, we were able to calculate a bit of a formula. What would our formula at R of I be? So kind of looking at this one right here, we could say that it would be the max of R. So if this is 4, this is 3, we would say the max of R of I minus 1. 4 minus 1 is 3. Or we could say it's R of 4 minus 2, right? 4 minus 2 is 2. So we could say I minus 2. And then this number right here was the value of our current, ith house. It was this house right here. So we would say plus R, or rather, not R, because we don't want the profit at R. We want whatever the item is. We would say array at I, if we were to call this an array. If I was to put array up here. Okay? And that's it. It's a dynamic programming problem. And basically what's happening is as we are moving down the line, as our robber is walking down the street, and that's kind of how I've learned to solve dynamic programming problems. And I'll put some links in the description for other other resources for dynamic programming problems. Truthfully and transparently, this is a field of a study that I am just getting into. So this is my opportunity to kind of learn with you guys. But this is what I understand so far is that we have a base case, which is a number here. Our base case at R of 0 is going to be 2. And from there, we're able to build up a array of basically the profits from whatever that one was. We actually have 2 base cases. It's basically the 0 and the 1 base case. And then this number 3, this third index right here, it's going to be based off of this one or this one, these two together. These two together. 2 plus 11. And we're going to continue that basically for the remainder of our list. So if you have any suggestions on how to explain things better or how I could have explained things better, I'm totally open to it. But let's get into the programming. Okay, so here we are. We're on LeetCode question 198, house robber, and we've already determined that the way that we're going to do this is we're going to have to solve for a few base cases. Now, it gives us a couple base cases here, and it says that if the length of this array is going to be between 1 and 100. So we don't have to solve for a length of 0. And it also says that the numbers within the array are going to be positive up to and including the 400 right here. So this is good stuff. This helps. And so what we're going to do is, because we know that our array starts at 1, we're going to say if the length of our array, or rather our array of nums, is equal to 1, what do we want to do at 1? Well, the length of our array is equal to 1, and that means that we have just a single digit here. So just one thing here. And we just want to basically return that value, the array at that value. or rather the nums at that value. Nums at 0, because nums at 0 would give us that one value that would be right there. Now, what's going to happen at our nums value of 1? Okay, so this is the second number in our array, but it's basically the 7 in this array right here. What's that going to be equal to? Well, we already determined from our system over here that the profit at 1 is going to be equal to the max of the first number, which was a 2, and 7. So 2 and 7, what's the max of those two numbers? We're going to put that right here. We're going to say the max of nums 0 and nums 1. So that's going to cover us for the first two base cases. We know that nums of 0 is going to be as it is. It's just going to be a 2. And nums of 1 is going to be the max of 2 and 7. So for instance, if the first number was 7 and the second number was 2, we would want our nums of 2, this one right here, we would want it to be the maximum of the 2, because a robber that is, at say, if our robber is at this house right here and this house right here, he's going to obviously pick the 7 because it's the greatest of the 2, and he can only rob one of them. So now we want to loop through basically the rest of the array. And so how are we going to do that? We're going to say for I in range, and we want the range 2 to the length of the array nums. This is also considered a list in Python. And what we want to do is we want to basically do our formula that we set up right here. And our formula was r of I is equal to the max of r of I minus 1 or r of I minus 2 plus the element at that array I. So we're going to say the nums, if you will, at I is going to be equal to the max of the nums at I minus 1 or nums I minus 2 plus nums at I. Why would we say plus nums at I? Because nums at I, if we were at the 9 right here, we're going to either say we want to have the maximum between either 9 plus 2, which would be 11, or we want 7, because we can only rob the first one and the third one here. I hope we can follow this together, or the middle one. Okay, I hope that makes sense. And then so what this is going to do is it's going to basically replace the number in our array prior to whatever we are at now, whatever index we're at now. So when we're at index 2, we're going to replace index 2 with whatever that max number is, and then when we go to index 3, we're going to replace that number with our new max, and it's going to carry over kind of like we had here, right? Each of these numbers are carrying over, where we had the 2 and the 7, which was our base case, the 2 and the 7, which was our base case, and then we just kept kind of adding to it, right? And we can even see that right here. We're adding the numbers that were in the array, the previous numbers in the array. And because we're at 2, right? The furthest back in the array that we can go is 2. So if we were at, let me clear this up a little bit. If we were at the 11, we could only go back to the 2. Whatever. This is 2. This is 1. This is 0. So the 2 would be our I, and then we would subtract 2 minus 2. So 2 minus 2, which would be 0. So we would be looking at this guy right there. And so we're good because we're never going to be out of bounds because we already are. We're starting at 2 right here. We're starting at 2. So then what we want to do is we basically want to say, okay, great. We have now filled in our entire array with the max of whatever the item in the array prior to was, or 2 prior plus the number at that current element. We want to return. If that confused you, then don't worry about it. It's okay. We want to return our nums, excuse me. We want to return our nums at the end of the array. And that's what this -1 does. It tells Python to go basically from the back of the array, subtracted 1. So it would give us this last index right here. And let's kind of take care of the space and time complexity of this. The space and time complexity will be, well, we're having to run through every element in our array at least once, right? So we're going to have a big O of n time complexity, and we're going to have a big O of 1 space complexity, where n is number of elements in nums. Let me explain. Why is it big O of n time and constant space? Because we're only running through our nums. Really, we're only looping through it nums minus 2 times, but we're going to drop that non-dominant term, so it's really going to be the length of the nums that we're going to iterate. And then the reason why it's constant space is because we are not creating any auxiliary arrays. There's no recursion going on here. So this is our solution in our algorithm. Let's see how we did. All right, it worked. I'm glad it did. And it looks like it's rather performant and also rather space efficient. All right, hope that helped.